Hello friends, in this lecture we are going to see instruction set of 8086 microprocessor. Now what are the instructions are nothing but different types of operation which is being performed by microprocessor. Now different types of operations are nothing but something data moved from one register to another register, some arithmetic operation, that is addition, subtraction, like that, some logical operation, and there are a number of different operations can be performed by using microprocessor. Now these operations are being performed by the microprocessor given by the instructions by the user. Now depending upon the different types of operation, the categorization of instructions is being done, and depending upon that operation we are going to see what are the different types of instructions. So firstly we are going to see what are the different types of instruction. So firstly, data transfer instruction. Second is arithmetic and logical instruction. Third is branch instructions. Fourth is loop type of instructions. Fifth is processor control instructions. Sixth is flag manipulation instruction. Seventh is shift and rotate instructions, and eighth is string type of instruction. Now these are the 8 major categories of instruction for 8086 microprocessor. Now we are going to see each and every type of instruction, and in that instruction which are the instructions available for the user. Now depending upon that we are going to see the operations of the instructions. So firstly we are going to see the data transfer instruction. Now data transfer instructions are nothing but where the data is transferred between the register to register, or immediate value to the register, or immediate value to the memory, or memory to the register. So depending upon that there are number of different types of data transfer instruction. Again there are some data transfer between the flags, data transfer between the input port and output port. Depending upon that we are going to see the different types of data transfer instructions. So first is MOV. MOV is nothing but the mnemonic for that instruction, and the instruction is named as move. Now what this instruction does, this instruction copies the contents of source, whether it is a memory or whether it is a immediate data or whether it is a register, to the destination. In destination we can have the register or memory depending upon the instructions. So what this instruction does is it copies the data from source to destination. As the name indicates, it moves, but actually it copies the contents from source to destination. Now we will see what operation is being performed by this instruction with the help of some examples. Now first example I am taking it, move AX, 0000H. Now this is the instruction which copies this immediate value, that is 0000, to AX register. So that means this is the source operand. The contents of this source operand is being copied to the destination operand. Now in our case the destination operand is AX. So that means after this instruction, now let's say for example if the contents of the register before executing this instruction is 1111 in hexadecimal, after executing this instruction the contents of AX will be modified as 0000H. So after execution we will get this result. So that means the contents of source is copied to the destination. Now in this example of a instruction, the source is immediate value and the destination is AX register. Now similarly we will see some other examples. Now second example is move AX comma BX. Now in this case, what this instruction tells us that the contents of BX register will be copied to the contents of AX register. Now in this case, both the registers are of 16-bit. So the 16-bit data is transferred in this case. So for example, we will take contents of AX before execution is 1111H. Contents of BX before execution is 2222H. Now after execution of this instruction, the contents of AX will be 2222H, and the contents of BX, we are not changing this contents, that's why it is 2222H. So this is the second example of instruction. Now here in the first case the source is immediate value, in the second case the source is register. Now we will see one example where the source is a memory value. So how we are referencing a memory is nothing but we are writing the address. Now for writing the address we will use the square bracket, and in this square bracket we specify the offset address. So let's say I am writing the offset address as a 2222. Now what this instruction says is that the contents of the address 2222 should be copied to the BX register. Now we will take again example 2222. This memory carries two values, for example 1, 2 and 3, 4. Now here if you can see that I have represented in each memory location the 8-bit data is stored, 8-bit data over here and 8-bit data over here, because in each memory location only 8-bit of the data can be stored. So after execution of this instruction, this data which is 1, 2, 3, 4 will be copied to BX register. Now how it is copied is nothing but after this execution the BX register becomes, BX will be, this value will be moved to the BL register which is lower significant byte, and the second value will be moved to the BH register. So the contents of BX will be 3412H. So this is how the first of all the source is now 2222H and the destination is BX register. Now similarly we can have the destination also as a memory and source can be register. So I will write the remaining example. So first example I will write it as 2222H. So this is a memory location where I am forwarding the value 0043H. So here the source is immediate value and destination is memory. In second case we will write move 2221 from AX register. The contents of AX register will be copied to memory location 2221. Now these are the number of different ways in which we can write the program, or in which we can write the instruction of a move. Now the special thing we have to see over here is we cannot write move DS comma 1111H, which is where we are signifying some data to the segment register. Now this register is not available for the immediate addressing. So whenever we have to store some value to the DS register, we have to use some another register. So for example, if I wanted to move the data 111H to data segment register, we have to use some another register. For example, move BX comma 1111H. After that, move DS comma BX. So these are two instructions can be used for the respective operation. Next data transfer is push instruction. This push instruction is used for temporarily storing the data to the stack. Now where this data is transferred or when this data is required to temporarily stored. So whenever the any execution of main program need to be changed, at that time the sequence of the program changed from main program to the another program. So in that case we have to store the current contents of the register or the memory to some temporarily storage memory. At that time the push instruction is used for storing some contents of flags or some register. Now we'll see what actually push instruction does. So basically push instruction copies the contents of the register to the memory location, and the memory location is nothing but stack. Now stack normally is addressed by two registers, that is stack segment register and stack pointer. Now what operation is performed in this push instruction is the contents of stack pointer is decremented by 2 and the contents of the current operand is pushed, that is copied on the memory. So as I have stated that the contents of the stack pointer is decremented by 2. So that means the value is decremented by 2 and the operand is pushed on the stack. Now as we know, stack is addressed by this two register, that is stack segment register and stack pointer. Now how this operation is performed, we will see with the help of one of the example. So we will write push CX. Okay, so the contents of this CX register will be pushed on the stack. Now stack is pointed by 1 0 0 0 and 3 3 3 3. That means the current contents of stack pointer is 3 3 3 3, which is in hexadecimal. So if I draw a memory like this, these are the consecutive memory location. So first current stack pointer is 3 3 3 3. Below that there will be second location 3 3 3 1 and 3 3 3 0. Like that there will be number of locations in the stack segment. Now our contents of CX for assumption will take 1 1 and 2 2. Now what this 1 1 2 2 signifies? 2 2 will be stored in CL register and 1 1 is stored in CH register, which you have seen in the storage of register. Now how this operation is performed, the contents of this CL will be moved to the 3332, that is 22 over here, and the contents of CH register will be moved to the 3331 and the stack pointer is changed to 3331. So now stack pointer always carries the current top of the stack. So now the stack pointer is changed to 3331. Now if the next operation is performed after this, the stack pointer again will be decremented by 2 and the location will be copied. So now for example we will take another instruction, push BL. Now in this case, if you can observe, the operand which is being specified is of 8 bit. So in this case stack pointer is not decremented by 2, the stack pointer will be decremented by 1 only. So stack pointer goes to stack pointer minus 1 and the contents of BL will be moved to the 3330. So if BL carries A4H, after execution of push BL instruction, stack pointer will be changed to 3330 and the contents of 3330 will be A4H. So this is what happens in the push instruction. So basically push instruction copies the contents of the operand to the memory pointed by stack segment register and stack pointer. Again we can write some memory also in this operand. For example push 0001H. So here we are specifying the address. So this is the second instruction in the data transfer instruction. Now we will see the third instruction in data transfer instruction is pop. Now pop instruction is just reverse of the push instruction. In the push instruction we have copied the contents of register or memory to the stack. Now if you wanted to take back that contents of the memory location in the stack segment, we have to use the pop instruction. Now what this pop instruction does is, pop instruction copies the contents of current stack pointer to the register or the operand which is being specified. So what is operation performed is nothing but, we will see with the help of one of the example. Now let's say I have written pop cx and current contents of stack pointer is nothing but 3330. Okay, so this is the current top of the stack, and this contents will be copied to the cx register. Now this is the location 3330. Above that there will be 3331, 3332 and so on in the incrementing fashion. Now after this pop instruction, these contents will be copied to cx register because the current stack pointer is 3330. Now where it goes, so if I am taking this value as a 31, this value as a 32, this value will be moved to the cx register after pop operation. So this value will go to the ch register, that is 31, and this value will go to the cl register, that is 32. So after execution of this instruction, that is pop cx, the contents of cx will be 32 and 31. Now what will be the contents of stack pointer? Now stack pointer will be incremented by 2. That means if the current stack pointer is 3330, it will be incremented by 2, that will go to the next stack pointer, that is 3332. So this is what happens in the pop instruction. It is just the reverse of the push instruction. Next instruction in the data transfer instructions are exchange. The mnemonic for that instruction is XCHG, which stands for exchange. So if I am writing the example of exchange instruction XCHG CX comma BX, in this instruction the contents of source copies to the destination and the destination copies to the source. Unlike in the move instruction, the contents of source copy to the destination only. Nothing happens from destination to source. So in the exchange instruction, the contents of BX is copied to CX and CX is copied to BX. So if before the execution CX is 1111H and BX is ABCDH. Now since it is a hexadecimal format, we can write the mnemonic also. So after execution, we can have the contents of CX as ABCDH and the contents of BX will be 1111H. So this is what happens in the exchange instruction. Now which are the different types of operand available in the exchange? So firstly, we can write both the register, which we have seen in the case of first instruction. Now in this second case, we can write address over source and destination also. So we can write exchange 1000 dx. So the contents of dx will be copied to the 1000 location and 1000 to the dx register. So but in the exchange instruction, we cannot write both the memory operands as same as move instruction. In this case, this instruction is not possible because both the operands are not specified in the operand field, and also in exchange instruction we cannot write any immediate value. So this instruction also not possible in the exchange format. So this is the exchange instruction for transferring a data. Next instruction is in. Now in instruction is nothing but used for copying the data from port to the input register, and this input instruction is used basically to copies the contents of port value to the register. Now in this specifically we can write only the one register, that is AX or AL. So if I am writing the instructions like in AX comma 03H. So now what this instruction does is it copies the contents of 03 port to the AX register. Now this is nothing but address of a port over here. Now again we can specify the port address by using different register. For example, I can write in AX comma DX also. So with the help of DX register I can specify the 16-bit address of a port. So before using this instruction I need to use MOV DX comma, let's say 2200H. So before using this instruction I need to modify the contents of DX register. So what this instruction does is it copies the contents of a port to the register, but in 8086 the registers which is used can be AX or AL only. So this is the special use of AX or AL register. Now what is specific in the in and out instruction is, in this case memory and IO signal which is multiplex, in this case only IO signal is enabled and read write signal is used depending upon whether we are using the in instruction or out instruction. Now the next instruction which we are going to see is out. What this instruction signifies, it copies the contents of the register to the respective port. Now in this case the destination is nothing but the port. So if I am writing the syntax for the out instruction, out port address comma AX or AL. So it will copy the contents of register to the port. So for providing the data to the port we are using this out instruction. So for example I can write out 43H comma AL. So here the contents of AL register will be copied to the port which is at whose address is 43H. Similarly I can write out DX comma AX. Now here I am specifying address of a port by using DX register. So this is a special case and special function of AX and DX register. The special function of DX register is it is used for providing the address of a port and the special function of AX register is whatever the data need to be forwarded to the port should be forwarded from AL or AX register only. Next instruction which we are going to see is nothing but push F, which is signifies push flag register to stack. Now we have seen push instruction. The same operation is performed for this push F also, only the contents of flag register is copied to the stack. Unlike the previous instruction where we are specifying the operand can be a memory or the register, in this case the operand is fixed, that is nothing but a flag register. Same operation is performed, stack pointer is decremented by 2 and the contents of flag register is moved to the stack segment. Next instruction is pop F. Now what this instruction does is pop flag register from stack. So it copies the contents of a stack and it moves to the flag register. So stack pointer contents move to the flag register of 8086. Again, what is the second operation performed is stack pointer is incremented by 2. So this is the instruction which is being performed in the push and pop for flag. Instruction set of 8086 microprocessor. Next instruction which we are going to see is LAHF. that is load AH from lower byte of flag register. Now in this instruction, the contents of the flag register is moved to the AH register, but as you can see in LAHF instruction, the operand is AH register. Now because of that, we can only transfer 8 bit, and which 8 bit is to be transferred is nothing but lower byte. So what operation is performed is contents of flag register, and in which 0 to 7 bits are transferred to the AH register. So this is called as LAHF, that is load AH from lower byte of the flag register. Similarly, there is a second instruction called as SAHF. When we have to modify the contents of flag register, we can use this SAHF instruction. So what this instruction says that store AH to lower byte of flag register. Now here the contents of AX is copied to the flag register. So AH is copied to flag register. The bits are 0 to 7. So these are two instructions for modifying the contents of flag register. Now basically, if we relate the data transfer instruction, here the operands are AH register and flag register. Now next instruction is LEA, that is load effective address. It will load the effective address which is being written in the instruction. Now what do you know effective address is? Whenever in the instruction of the 8086 microprocessor, the labels are used in the programming, wherever the labels are used, sometimes it is not able to find out which label signifies which address, whether it is a segment address or offset address. So for knowing the offset address of that respective label, we are using the load effective address. So for example, I can write LEA BX comma ADDR. Now ADDR is nothing but a label. Now this label will be available in the memory somewhere. Now the effective address of this label will be copied to the BX register. So let's say the address of this ADDR is 1000 and 1111. So in this case, the first address is segment address and the second address is nothing but we call it as an offset address or a effective address. So this effective address will be copied to the BX register. So after execution of this instruction, BX will be having the value 1111H. Okay. So this is load effective address instruction. Now the next instruction in the data transfer type is LES or LDS, which stand for load data segment or extra segment from the memory location available in the instruction. So if I am writing the instruction, for example LES BX in bracket CX, so here the two operations are performed. First of all, the contents of BX also modified and the contents of LES or LDS also gets modified. So here, now let's say CX is having the address 0002. Now 0002 is nothing but the memory address, and in that memory address some contents will be stored. So if the memory address 0002 is stored with some value 0003, 0004 will be having some value, and the contents are, for example, I am taking 1122 3344 because each memory location can able to store only 8 bit of the data. So after executing this LESBX comma in bracket CX register, CX carries 0002, the BX register will be stored with the value 2211, which is, first of all, this value will move to the BL register and this value will move to the BH register, that is higher significant byte and lower significant byte, and this value will move to the ES register. So ES register will be having value 4433H. So in this case, the contents of memory which is available in the instruction will be copied to the BX register or the destination operand, as well as the modify the contents of extra segment register, as well as we can write it for the data segment register. So for modifying the contents of segment register, which is extra segment or data segment, we can write LDS or LES. Now last instruction in the data transfer instruction is XLAT. XLAT means translate. Now whenever there is a operation which is being performed for translating some data, which is nothing but, for example, some lookup table is available to us, and lookup table is used for signifying some ABCD contents to the respective mapping of numbers. So for giving that mapping to the respective numbers for 1, 2, 3, 4, we can use the XLAT, that is translate. So for example, we can use for changing the number to the ASCII values, and the ASCII value will be stored in the some memory location. So XLAT is used basically for translating some operation, and for that translating we have to store some values into the memory location. So what operation is performed in the translate is, by default it has the operand specifics, that is AL and DS, BX and AL. Now what operation is performed in this instruction is, the contents of AL will be forwarded to this XLAT instruction, and the new effective address is being calculated by the contents of BX plus contents of AL, and this new address will be transferred to that, and the contents of that will be transferred to AL. So for example, if I am taking the AL as a 02, BX as 1111, and the contents of DS is equals to, let's say, 0001. Okay. So the now how the memory is located for data segment is, it will be found the effective address by using two registers, that is data segment register is 0001 and 1111. So it will be having some value, for example 01, 02, 03 and so on. Now for example, I am taking BX DS as a 0001. Now what will happen in this case? So as it is stated, the BX is nothing but 1111 plus AL is 02. So the new address which is found out is nothing but 1113. So 0001, 1112, 0001, 1113. So this is the new location, and the contents of this new location, which is 03, will be transferred to the AL. So after execution of this instruction, AL will be modified as a 03. So this is what happens in the XLAT instruction. So we have translated one value with the second value which is available in the memory. So in this case, we have seen the different types of data transfer instructions, starting from move to the translate. Thank you.